Sometimes we can use the recursive procedure to find out a specific pattern in the sequence. For example, for this sequence, 1, 2, 3, 5, 8, 13, 21. In this sequence, we cannot find out the common difference between two consecutive terms. The difference is 1, but the difference is 2. This difference is 3, 5, 8. But you can find out a spatial pattern that you say from the third term, the term equals the sum of the previous two terms. For the fourth term, it is the sum of the previous two terms. 2 plus 3 equals 5. For this term, it equals the sum of the previous terms, and so on. In this situation, we can express the spatial pattern like this. T1 equals 1, T2 equals 2, T3 equals T1 plus T2, T4 equals T3 plus T2, and so on. But for this term, T2 cannot be expressed as T1 plus T0 because in the sequence, we cannot find the term T0. So this pattern will be found from the third term. From the third term, we can generalize this recursive procedure. Tn equals the previous term, Tn minus 1 plus the previous term, Tn minus 2. But here, n should be greater than 3 or equal to 3. The recursive procedure starts with the third term. But for the first term and the second term, you need to indicate the exact value for the first two terms. This kind of procedure or spatial pattern, we name it as a recursive procedure. Let's summarize. What is the recursive procedure? On the basis of the previous term or terms, we can get the current term in the sequence. Current term can be calculated from the previous term or terms. This kind of sequence, we can use recursion formula to indicate the relationship between the terms in the sequence. That you say, for this example, the recursion formula should be composed of this one, and this one.